Every time you save a photo or a document or, well, anything to the cloud, you're tapping into one of the most complex, invisible systems ever built. Today, we're going to pull back that curtain on the hidden science that makes it all possible.
I mean, just think about it for a second. Your entire digital life, it all lives in the cloud. But what's the secret sauce that keeps this whole thing from just collapsing under its own weight? That's the big question we're digging into today.
So, to even begin to wrap our heads around this, we first have to grasp the sheer, mind-boggling scale of the problem. Welcome to what we're calling the Exabyte Challenge.
This quote from the Dropbox tech blog really puts it in perspective. We're not talking about gigabytes or even terabytes here. We are talking about exabytes. An exabyte is a billion gigabytes. Let that sink in. And on top of that, these companies are juggling trillions of file revisions. It's just an absolutely astronomical amount of data.
Now, when you're faced with a mountain of data that big, you'd think the costs would just be through the roof, right? But here's what's so fascinating. There's a single key technique that can lead to these massive savings. We're talking up to 83%, according to studies from giants like Microsoft and EMC. So, how on earth is that even possible?
Well, the answer is this incredibly clever bit of science called data deduplication. Honestly, this is the fundamental building block that makes the modern cloud work. It's really the art of not repeating yourself, but on a massive digital scale. So here's the core idea. Instead of saving the exact same chunk of data a million times just because a million people have it, the system is smart enough to store it only once. Every other copy is just a tiny little pointer back to that original chunk. It's a beautifully simple concept, but as you'll see, it gets incredibly complex in practice.
And this right here, this is the huge problem they had to solve. Just look at these two files. File B is basically just file A, but with one tiny little bit of content inserted in the middle. Now, a simple, kind of dumb system would see every single block of data after that insertion as completely new, even though it's all identical. This is called the boundary shift problem, and it's a total deduplication killer.
So how do you fix that? With something really, really smart called content-defined chunking, or CDC. See, instead of cutting files into chunks at fixed spots, these brilliant algorithms create the boundaries based on the content of the data itself. That way, no matter where the data moves or gets shifted, the system can still find and recognize all the identical chunks. It's genius.
And this isn't just one simple idea. It's a whole field of computer science that's been evolving for decades. Researchers have come up with all these different approaches. Some use what's called a sliding window to look for patterns as they scan through a file. Others look for local extrema. You can think of them like peaks and valleys in the data stream to decide where to make the cuts. And some even use statistical analysis. Each one is just a different, clever way to solve that same fundamental boundary shift problem.
Okay, so that's the micro level, the nitty-gritty science. Now let's zoom out a bit and see how this powers the automated safety nets that we all rely on every single day.
I mean, when you compare modern automated backup to the old way of doing things, like literally having someone go find a physical tape in a library somewhere, the difference is just night and day. Thanks to technologies like deduplication, online systems are way more reliable and secure, and they scale effortlessly. And the crucial part? Recovery isn't about waiting hours for an operator, it's about getting all your data back with just a few clicks.
What this all boils down to is a system that you can pretty much set and forget. It means if something goes wrong, you can get back online fast. It's ready for audits, it scales as you grow, and it works for teams spread all over the world, all without you ever having to see or touch a single piece of hardware.
But look, to make all those promises stick, these services have to be built on a truly global scale. So let's zoom out from the individual file to the massive infrastructure that acts like a fortress for our data, what's known as the cyber vault.
A cyber vault is, well, it's pretty much exactly what it sounds like. It's an isolated, super secure architecture that's designed from the ground up to protect your backups from everything: ransomware, malware, insider threats, you name it. It's built to make sure that attackers can't get to and can't delete your absolute last line of defense. And who builds these incredible things? The major cloud providers. Companies like Amazon Web Services operate these massive, geographically dispersed systems, data centers spread all across the globe, to create these digital fortresses for all of us.
And building one isn't just flipping a switch. It's a really deliberate, multi-step process. First, you define all your backup policies. Then, you secure the vault itself with encryption and super strict access rules. Next, you copy that data to multiple continents for disaster recovery. And finally, and this is the critical part, you engage a vault lock that makes the backups truly unchangeable.
Once it's locked, that data can't be altered or deleted, not even by the account owner. It's locked tight. Okay, so we've journeyed from these tiny chunks of data all the way up to globe-spanning digital fortresses. Now let's bring it all back home, to your computer, and talk about the beautiful illusion that holds this all together.
I mean, after everything we've just seen, the content-defined chunking, the global cyber vaults, the immutable locks, how does the end result feel so simple? How is it all just a magic folder on your computer that just works?
Well, the short answer is because making it simple is unbelievably mind-blowingly hard, and the stakes are huge. As Dropbox pointed out when they had to rewrite their sync engine, a total rewrite is often called the single worst strategic mistake a company can make. And why is that? Because it's a massive risk that can just halt all other innovation for years.
And that right there, that's the ultimate takeaway. That seamless magic folder experience is an illusion, but it's the entire point of the whole system. Engineers have to wrestle with every single layer of this complexity, from those little algorithms that chunk your files all the way to the vaults that store them globally, all to create and preserve that feeling of effortless simplicity for you.
So as our collective data continues to grow exponentially, it just leaves us with this one critical question. What comes next? What new, invisible science are we going to have to invent just to keep our entire digital world from collapsing under its own weight? Because this challenge, well, it never, ever ends.